Hello everyone. In this video we're going to be solving an exponential equation. We have x to the power 6 equals square root of 2 to the power square root of 2. And we're going to be solving for x values. So let's go ahead and make one thing clear. First, whenever we have something like a to the power b to the power c, it's meant to be a to the power the quantity b to the power c, not a to the power b to the power c, because this could be written as a to the power bc. So here the exponent is bc, and here the exponent is b to the power c, which is another exponential. Make sense? So we're gonna go with the first one. The second one is not what we mean by this. Okay? So when we have something like this, there's actually a general method you can use, and I'll be presenting two methods. My first method is going to be using substitution. So I'm going to go ahead and do the following. Let's replace x to the 6 with something. How about calling that t? So we're going to call x to the 6t, and that's going to give us x to the power t equals square root of 2 to the power square root of 2. Great. Now, since we got x to the 6 equals t, we can go ahead and solve for x here in terms of t, and then plug it in here. Let's go ahead and do that next. So from here we can basically write x as t to the power 1 over 6. So here we have to be a little careful, because because we're using an even exponent, t must be positive, but x can be negative or positive. So if we're dealing with real numbers, we may have to use minus t to the power 1 over 6 as well. But when we find the solutions at the end, I'm going to show you. Let's just go ahead and stick to the positive version first, because that's a little easier. And then with the second method, by the way, this is the first method. With the second method, we're going to go ahead and focus on both solutions. Okay? So let's go ahead and replace x with t to the power 1 over 6, and then we're going to raise it to the power t, and that'll equal square root of 2 to the power square root of 2. Great. Let's go and multiply the exponents. T to the power t over 6 equals root 2 over root 2. Now what should I do here? I have t to the power t over 6. We can go ahead and raise both sides to the 6th power, or actually we can do 1 over 6th power. Either way is fine. Let's go ahead and do 1 over 6. So now we can go ahead and write this as, actually, I could probably just do 6th power. That looks like it's going to be easier. So let's raise both sides to the 6th power, and that's going to give me square root of 2 to the power 6 square root of 2. And obviously you can write this in so many different ways, but let's go ahead and try to find t from here. We can definitely use Lambert's W function. So you can use W. W is defined as if you have w x e to the x, it's equal to x under certain conditions, of course. This is basically the inverse function for x e to the x. So from there, but we need to natural log both sides. So here's kind of how it goes. I'm not going to do the whole thing, but I'll kind of show you how this can proceed. We can ln both sides, and then move the exponents to the front. It's going to give us t ln t equals 6 root 2 times ln root 2. And then we can basically write the t as e to the power ln t, and then this is going to be a constant. Let's call that k for now, because later on we can take care of it. Let's just leave it at that. And now this is actually in this form, but we need to do a little bit of substitution. So let's go ahead and call ln t something. How about calling this y? So we get y e to the y equals k. And when you use Lambert's W function on both sides, you're going to get the y on the left-hand side. If you w both sides, this is going to give you y equals Lambert W of k. But k is a constant. You can plug it in, input this into Wolfram Alpha, and that's going to give you the answer. Or we can proceed a little differently by manipulating the powers, the radicals, and so on and so forth. So let's go ahead and try to do this without Lambert's W function. So we got t to the power t equals root 2 to the power 6 root 2, right? Okay. Now, my goal is to make the base and the exponent the same thing. Make sense? And that can be done. As you see here, the base is smaller, right? So we got to make it bigger. And one of the things we can do is we can actually break this down into factors so that we can use one of them as an exponent for the base. Make sense? So in other words, when you have something like a to the bc, you can basically write it as a to the b to the c. Or if you have a to the power b, c, d, if you have more than two factors, then whatever you want, you can put it inside and everything else will be outside. Make sense? Okay. So let's go ahead and see what we can break off. So I'm thinking about 6 root 2 can probably broken down into 2 times 3 root 2, 3 times 2 root 2. Those are kind of like logical, right? So which one would you go with? Let's go ahead and try the first one first, right? Because that's the first one. So how about breaking the 6 root 2 as 2 times 3 root 2 and then bundling these up together? That's going to give me square root of 2 to the power 2 and then that to the power 3 root 2, because that's when the exponents are multiplied. Square root of 2 squared is just 2, and this gives me 2 to the power 3 root 2. Obviously, that did not give us the same base and the exponent, so this choice did not work. Let's go ahead and go with the second one. T to the t equals square root of 2 to the power 3 times 2 root 2. Now I'm going to go ahead and package these together so that this becomes square root of 2 to the third and then that to the power 2 root 2. But what do you think square root of 2 cubed is? It is basically square root of 2 times square root of 2 times square root of 2, but this is just a 2. Therefore, it's just going to be 2 root 2 to the power 2 root 2, and that's actually awesome because from here we're going to get t equals 2 root 2. But what is t, right? T is, let's find out. T is x to the 6th power, therefore this is going to equal x to the 6th power, and you can basically find x from here, because remember there's going to be two solutions. As far as I know, we could check that. If you look at the original problem, it said x to the 6 equals root 2 to the 2. So even if x is negative, we're going to have a positive exponent, negative base. This should work. So from here you can basically do the following. Let's go ahead and write this as 2 to the power 1 times 2 to the power 1 half, which is 2 to the power 3 halves. And then now raise both sides. 2 to the power 1/6. X is going to be 2 to the power 3 over 12, which is 1/4. So you can basically write this as the 4th root of 2 or the opposite of that. Now let me quickly go over what the second method is going to look like. And it's going to be very, very similar, super duper similar to the first method. That's why I don't want to spend too much time on it, but just show you the outline. So here's what we're going to do, and this is a general principle. Anytime you see x to the n, always raise it to the nth power, because that's going to give you something good. Now we're going to raise both sides to the power 6, which is determined by this exponent. So let's go ahead and raise to the 6th power both sides. That's going to give me x to the 6 times x to the 6 equals, you can go ahead and write it again like this, and you know how to break it down now, right? This was 2 root 2 to the power 2 root 2, as you know. That part is fine, but what about the right hand side? I mean the left hand side. You can go ahead and put the 6 and the x together. That's going to give you x to the 6 to the x to the 6, and again you're going to be going through the exact same thing, which gives you the exact same answer, and that will be x equals the 4th root of 2 or the opposite of that. You can put a little minus sign there, and that'll be the solutions. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.